Here's one last example involving an integral and e to a power. This is a definite integral from 0 to 1, so that's going to be a little bit different from the previous videos. And as we'll shortly see, the substitution we're going to make won't involve the exponent. It's going to involve a more complicated expression. And be careful, while a lot of the examples we look at that involve e and integration, we do end up making the substitution for the exponent. That's not the only type of substitution we can make. For instance, here we can say that u is equal to 1 plus e to the x, and therefore du is equal to e to the x dx. That gives us a nice substitution to make. Now, since we're going to be moving a definite integral into the variable u, we also need to consider the limits. So we're going to end up with e 1 plus e to the 1, or just 1 plus e. And when we plug 0 in, we're going to have 1 plus e to the 0. Well, anything to the 0 except 0 itself is 1, so we're going to have 1 plus 1, or 2. So this is going to end up looking like the integral from 2 to 1 plus e. There's a funny looking upper limit of integration, but it works. That's a number. And we're going to end up with 1 over u du. So that's going to be equal to the natural log of the absolute value of u evaluated from 2 to 1 plus e, or that's going to be the natural log of 1 plus e. It's positive, so I don't have to worry about the absolute value signs, minus the natural log of 2. 2 is also positive, so I don't have to worry about the absolute value signs. You can leave them in there if you choose. It doesn't hurt anything. If we wanted to, we could write that as the natural log of 1 plus e divided by 2. Either version of the answer will work. I'm not going to be picky about which one. I just want to remind you that we still do have those properties of logarithms that do allow us to write things into different forms.